this lecture, we will going to see about the topic Halley-Hamilton theorem. A statement for the Halley-Hamilton theorem: every square matrix satisfies its own characteristic equation. First problem is verify Halley-Hamilton theorem and also find A inverse and A power 4 for this matrix -3, 2, 1, 3, -1, -2, 1, 2, 3. First, we have to find the characteristic equation for 3 by 3 matrix. The characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Here, s1 is the sum of the main diagonal elements. We will find the values for s1, that is equal to -1. Next one is s2 equal to the sum of the minor of the main diagonal elements, that is -12. s3 is the determinant of a, that is -18. This substituting s1 and s2 and s3 in this equation, in this characteristic equation, that is lambda cube plus lambda square minus 12 lambda plus 18 equal to 0. By using Halley-Hamilton theorem, we have to prove that a cube plus a square minus 12a plus 18 the identity matrix. We have to prove these matrix values are 0. First, we have to find the a square matrix. Here, a matrix is -3, 2, 1, 3, -1, -2, 1, 2, 3. Multiplying a matrix, we will get the value for a square is 16 minus 6 minus 4 minus 14, 3 minus 1, 6, 6, 6. Next one is a cube. We have to find the value for a cube. A cube equal to a square into a. A square into a, that value is a cube value is -70, 13, 16, 50, -33, -23, 6, 18, 12. Next one is the characteristic equation for this 3 by 3 matrix is lambda cube plus lambda square minus 12 lambda plus 18 equal to 0. Substituting put lambda equal to a, we will get the value a cube plus a square minus 12a plus 18 into I equal to a cube matrix plus a square matrix minus 12 into a matrix plus 18 into identity matrix. Simplifying these matrices, we will get the 0 matrices. Therefore, Halley-Hamilton theorem is verified. That is, every square matrix satisfies the characteristic equation. Next, we have to find the value for the matrix A inverse. Multiplying A inverse on both sides from equation 1, we will get a square plus a minus 12i plus 18 a inverse equal to 0. 18 a inverse equal to minus a square minus a plus 12i. A inverse equal to 1 by 18 into minus a square minus a plus 12. Substituting these values for a square, a plus 12 into identity matrix, we will get the value for a inverse, that is -1, 4, 3, 11, 10, 0, 3, -7, -8, 3. Next, we have to find the value for a to the power 4. Multiplying a on both sides of equation 1, we will get a power 4 plus a cube minus 12a square plus 18a equal to 0. A power 4 equal to minus a cube minus plus 12a square plus minus 18a. Next one is we have to find a power 4. Substituting a cube 12a square into 12 minus 18 into a matrix, we will get the matrix for a power 4. Next one is use Halley-Hamilton theorem to find the value of the matrix given by f of a and a power 8 minus 5a power 7 plus 7a power 6 minus 3a power 5 plus 8a power 4 minus 5a cube plus 8a square minus 2a plus I. If a matrix is 2, 1, 1, 0, 1, 0, 1, 1, 1, 2. Next one is The characteristic equation of this 3 by 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is the sum of the main diagonal elements, that is 5, s2 equal to the sum of the minor of the main diagonal elements, that is 7, s3 equal to determinant of A. The characteristic equation of this A matrix is lambda cube minus 5 lambda square plus 7 lambda minus 3 equal to 0. By using the Halley-Hamilton theorem to get the value for a cube minus 5a square plus 7a minus 3 equal to 0, name it as equation number 1. Our expression is f of a is a power 8 minus 5a power 7 plus 7a power 6 minus 3a power 5 plus a power 4 minus 5a cube plus 8a square minus 2a plus I, dividing this polynomial into a cube minus 5a square plus 7a minus 3. Substituting a power 5 into a cube a power 8, a power 5 into minus 5a square minus 5a power 7, a power 5 into 7a power 6, a power 5 into minus 3a power 5. Cancelling these all terms, next one is a power 4 minus 5a cube plus 8a square minus 2a plus I. A into plus a into a cube is a power 4 minus 5a cube plus 7a square minus 3a. Subtracting these two equations, we will get a square plus a plus I. We have to find this expression dividend into quotient plus remainder. Our dividend term is by using equation number 1, we will get the value for 0. Therefore 0 into a power 5 plus a square plus a plus I, that is a square plus a plus I. Next, substituting a square matrix, a matrix and identity matrix, we will get the value for f of a, that is equal to 855030558. Next abbreviation is dividing this abbreviation expansion polynomial by a cube minus 5a square plus 7a minus 3. We will get the value for the remainder 127a square minus 223a plus 106. Dividend into quotient plus remainder. Dividend term is characteristic equation is 0, so we will get this expression equal to 127a square minus 223a plus 106. 127 into a square matrix minus 223 into a matrix plus 106 into identity matrix. Therefore, we will get the value for the polynomial. Next one is use Halley-Hamilton theorem for the matrix A equal to express as a linear polynomial in A. First, we consider the characteristic equation lambda square minus s1 lambda plus s2 equal to 0, where s1 is the sum of the main diagonal elements, that is 4, s2 is the determinant of A, our value is minus 5. The characteristic equation is lambda square minus 4 lambda minus 5 equal to 0. By using Halley-Hamilton theorem, every square matrix satisfies its own characteristic equation. Therefore, substituting, put lambda equal to A. Therefore, a square minus 4a plus minus 5y equal to 0. Our expression, our polynomial is, first polynomial is a power 5 minus 4a power 4 minus 7a cube plus 11a square minus a minus 10i. Dividing this polynomial by a square minus 4a minus 5i, that is remainder is a plus 5i. This long expression equal to dividend into quotient plus remainder. Dividend value is 0, therefore a plus 5i, which is the linear polynomial in A. Next expression is a power 4 minus 4a cube minus 5a square plus a plus 2i. Dividing a square minus 4a minus 5i, we will get the quotient a square and also the remainder a plus 2i. Dividend into quotient plus remainder. Dividend value is 0, therefore this long expression equal to a plus 2i, which is the linear polynomial in A. Thank you.